Everyone assumes autonomous agents just run, and we lose all oversight once they're live.
What if the AI decisions are checked against JSON-LD policies at runtime, like code review for every order release?
So the system could still be fast, but we'd have a traceable guardrail baked in.
Exactly. Combined with hash chain logs and role-based agent entitlements, you get real-time control without throttling automation.
Welcome to another deep dive. So, yeah, let's contextualize that dynamic because for years, the fundamental assumption among enterprise architecture teams has been that AI inside an ERP basically operates as a black box.
Right. It's a terrifying thought for most teams.
Exactly. If you're an architect listening to this, you know the underlying fear. You give an autonomous agent the keys to your inventory optimization or, your order release in SAP S/4HANA, and your oversight becomes entirely post facto.
Yeah, you're effectively waiting for the month-end reporting and just hoping a hallucinating algorithm didn't just drain your working capital.
Right. We've been trapped in this totally reactive audit posture. But the mechanics revealed in the latest SAP AI core release, they fundamentally dismantle that assumption. We are looking at a shift from post-facto reporting to proactive runtime governance.
Absolutely. And the core enablers making this possible are JSON-LD policy as code bundles combined with the S/4HANA log chain service.
It changes the entire governance paradigm. We aren't running a batch report on what the system did yesterday. We essentially have a cryptographical auditor writing shotgun with every single transaction the agent attempts.
Writing shotgun is a great way to put it.
But let's get into the friction points, because moving from the theoretical promise of AI to the actual nuts and bolts of integration into an existing SAP pipeline, that's where architectures usually break down.
Oh, without a doubt.
So we hear the term JSON-LD policy as code thrown around a lot. Let's break down the why and the how here. Like, why use linked data specifically, and what is it actually doing in the transport pipeline?
Well, the linked data component is what gives the AI its semantic context. Standard JSON just gives you key value pairs, right? They're basically just dumb strings of data.
Yeah, no real context there.
Exactly. But JSON-LD creates an ontology. It allows the autonomous agent to actually understand relationships. So it doesn't just read a flat rule.
So it's interpreting the environment.
Right. It understands that, say, product group X belongs to regulated category Y, which then requires compliance check Z. It provides the absolute boundary condition for the agent's logic.
Oh, wow. Okay.
And what is truly groundbreaking here is how SAP...
Okay, so when a production planning AI decides to autonomously release a massive batch of orders, it's hitting this JSON-LD policy bundle at runtime. It's reading the ontology to see if the action is legal within the enterprise framework.
Precisely.
Then we have the S/4HANA log chain service recording the action. How does the immutable hashing actually work here?
Well, every single time that agent makes a micro decision, the S/4HANA log chain service generates an immutable hash chain for the transaction.
A cryptographic log.
Yeah, it is a tamper-evident cryptographic log.
Yeah.
So if an internal auditor comes in, say, 6 months later, and asks why the AI approved a specific batch of raw materials under a specific set of constraints, you aren't guessing based on historical data snapshots.
You have the exact receipts.
Exactly. You have a forensic replay of the exact policy version and the system state that existed at that precise millisecond of execution.
Wait, let me put my architect hat on for a second, because this sounds like a massive operational headache.
I know where you're going with this.
Right. Because if we are cryptographically hashing and logging every single micro decision an agent makes, and we're talking thousands of decisions a minute, doesn't that inherently crush S/4HANA's performance?
It's the logical question.
Are we just trading a governance problem for a massive AWS or Azure infrastructure bill? Heavy governance historically kills the automation speed we are paying millions to achieve.
I hear you. But the architecture is specifically designed to bypass that bottleneck. The evaluation of the JSON-LD bundles at runtime is entirely decoupled from the transactional core.
Oh, okay, so it's not synchronous.
Right. The hashing process happens asynchronously. It does not block the order release, so the execution speed remains lightning fast.
Makes sense.
The agent makes the decision, the transaction fires, and the cryptographic logging basically trails right behind it without causing latency.
Okay, so compute isn't the issue.
Compute isn't the issue, no. However, and this is a big however, the storage of those hash chains introduces a completely different and very real operational risk.
The storage saturation.
Exactly. We are generating terabytes of immutable audit data. If you don't manage the log rotation on the business technology platform, the BTP logging store, you will eventually bring the system to its knees.
Wow.
Yeah. Not through compute limits, but just through pure storage saturation.
That's a great point. I want to look at how this impacts cross-domain architecture before we dive deeper into those risks. We are talking about cross-domain policy propagation. Let's say a business user is working in the SAP customer experience or CX governance UI.
Okay.
They author a rule. Let's say it's a cap limiting autonomous order quantities to 10% of the current forecast. Historically, keeping that rule synced with the backend was an absolute nightmare.
Oh, an absolute nightmare. You would have to manually duplicate that rule into the S/4HANA backend, or you'd build some fragile middleware integration to keep them synced.
Which inevitably breaks during an upgrade.
Literally every time.
Yeah.
But now, the same JSON-LD policy engine serves both CX and S/4HANA.
Wait, really? The
Uh-huh.
exact same engine?
The exact same. That 10% cap, authored in the CX UI, is instantly propagated and enforced by the production planning AI operating inside S/4HANA.
That's incredible.
Yeah, the duplicate rule sets are completely eliminated. The ontology is shared across the entire landscape.
Okay, so the architecture is sound on paper. But what happens when organizational pressure breaks it? Because these AI systems are so deeply embedded into the ERP pipeline, theoretical governance risks instantly translate into massive financial impacts.
Very true.
Let's look at the classic tension between deployment speed and system safety. How does the system handle an update to the AI itself?
Well, that is managed by the Agent Lifecycle Gatekeeper, or ALG. This is a microservice baked into the S/4HANA's cloud environment.
Perfect.
ALG enforces a strict three-stage gate for every single agent version. You got a test run, sandbox approval, and a production push.
So we have the standard test production pipeline. But what happens when the agent passes those gates, hits a live environment, and just immediately starts misinterpreting the live data?
That triggers the ALG's auto rollback mechanism. Automatically. If the agent is pushed to production and its key performance indicators drift by more than 2% from the baseline established in the sandbox, ALG just yanks that version and rolls the system back to the previous stable state.
So it is a literal automated safety net for autonomous systems.
Exactly.
Let's run a real-world scenario. Let's say it is a Friday night. There is a massive hotfix sprint. The AI ops team is under immense pressure to deploy a new version of the agent to fix a minor inventory routing bug.
I've been there.
We all have. So to speed things up, they temporarily disable the ALG microservice, bypassing that three-stage gate entirely.
A classic circumvention of process. It happens in IT departments every single week.
Right.
But in an agentic environment, the blast radius is exponential. Without that gatekeeper, the new agent version hits production directly.
And it hasn't been tested.
Right. So let's say its learning loop is slightly skewed by the live data. It encounters a sudden standard demand spike for a component, but due to the untested code, it misclassifies that spike as a critical supply shortage.
Oh, wow. And because the team disabled that 2% drift auto rollback to push the hotfix through, the agent just acts on that hallucination.
Precisely. It automatically cancels millions of euros in pending purchase orders to protect capital, completely starving the supply chain before anyone even logs in on Monday morning.
It perfectly illustrates how bypassing a technical gatekeeper, basically treating an AI update like a standard web app patch, translates instantly into an unforced financial disaster.
It's a completely different ballgame.
Okay, that's a bypass of the deployment pipeline. But what if the AI update is perfectly fine and a human administrator simply hands the agent the wrong keys? That brings us to cloud access control.
Ah, yes, Dynamic Role-Based Agent Entitlements, or RBAE.
Right. This is essentially SAP extending its classic authorization model into the cloud-native environment.
Yeah, enterprise architects can now define specific agent roles. So instead of using a generic system user account that has a massive, sweeping authorization profile.
Which is what everyone does.
Right, which everyone does. Instead of that, you create a, let's say, PP release agent. This agent inherits standard SAP authorization objects, but they are dynamically scoped.
Scoped how?
Per plant, per cost center, or per sales organization via a UI5 console. You can adjust its operating theater on the fly, tailoring its permissions to the exact context of the JSON-LD policy.
If you're an architect listening to this, you know the pain of mapping service accounts. This sounds incredibly flexible, but I have to assume the impact of a mistake here is a massive regulatory trap.
Oh, massive.
Let's say an administrator over-provisions an RBAE service account. They assign the PT release agent role to an account used across multiple plants just to save time.
And by doing that, they inadvertently grant that autonomous agent the authority to release orders for a high-margin plant that operates under a completely separate, highly strict regional regulatory regime.
Right. And the agent, doing exactly what its objective function tells it to do, optimizes the supply chain by firing off order releases in that restricted region.
Without a second thought.
And just like that, the enterprise is exposed to immediate compliance fines for unauthorized sales region activity. I mean, the agent didn't malfunction at all. It executed perfectly within the overly broad parameters it was given.
Exactly. It highlights the extreme danger of treating agent entitlements like traditional service accounts. Human users get tired, right? They have a natural rate limit.
Right. A person can only click so fast.
Exactly. An over-provisioned autonomous agent will execute thousands of non-compliant transactions in the time it takes a human to even log into the dashboard.
That brings up the internal audit side of this, actually, because if an agent is making thousands of decisions a minute, how do we prevent it from playing both sides of the chessboard? We're looking at segregation of duties, or SD.
Yes, SPGRC access control now includes an agent-specific OS analyzer.
Okay.
This tool scans the proposed agent role assignments for classic segregation of duties conflicts before the agent is ever deployed. For example, it checks if an agent has been granted both create purchase order and approve purchase order rights.
Which you would never want. But the blind spot isn't the software, it's the configuration. What happens if the GRC team configures the analyzer to ignore agent-generated authorizations?
Which happens because they assume, oh, it's a machine, it doesn't have malicious intent, so it doesn't need the same scrutiny as human employees prone to fraud.
Right, they just wave it through.
If the analyzer ignores those specific authorizations, the agent could silently obtain both the create PO and approve PO rights.
Oh, that's bad.
Very bad. You now have an autonomous actor circumventing internal financial controls. It can silently approve its own orders in a closed loop, just infinitely optimizing its own metric, until a manual external audit finally uncovers the breach.
It's like we are moving from a world where the system crashed to the system efficiently executed in a legal trade.
That's exactly what's happening.
These aren't IT bugs. They are perfectly executed business violations. If you're an enterprise architect or a Basis admin listening right now, how do you actually map this out? We need to translate these tools into a practical deployment playbook.
Let's do it.
Let's trace a single autonomous order release through the organization to see how this four-step framework should actually operate. Step one has to be defining the scope, right?
Exactly. Step one is define and scope. The process starts at the very top of the architecture. The Chief Architecture Officer, consulting with business process owners, defines the boundary conditions, that JSON-LD policy as code bundle we talked about.
Right.
They determine the absolute limits of the agent's authority. And parallel to that, the SAP Basis team scopes the dynamic RBAE to specific plants and cost centers.
So this ensures that the cross-domain rules, like our 10% forecast cap we authored in CX earlier, propagate correctly into S/4HANA without leaking into unauthorized sales regions.
You've got it. That's step one.
Okay, then step two is the compliance layer, stepping in before the agent ever touches a live environment.
Right. Step two is pre-flight GRC scanning. The GRC compliance team, reporting to the Chief Risk Officer, must run the agent-specific SWORD analyzer rule set.
To verify there are no closed loops.
Exactly. They verify that the proposed role assignments do not create conflicts, like the create and approve PO loop.
Makes total sense. Step three is ops.
Step three is lifecycle gatekeeping. Once compliance signs off, the VP of AI enablement and the AI core ops team take over. They configure the ALG.
The gatekeeper.
Right. They lock down the three-stage gate test, sandbox, prod, and mandate the 2% drift auto rollback. The critical directive here is establishing a culture where the ALG is never, under any circumstances, bypassed for hot fixes.
None of that Friday night cowboy coding.
Exactly. And finally, step four, we hit the runtime environment.
The agent goes live.
Right. Step four is runtime guardrails and auditing. This is where finance and basis take the wheel. Finance sets the cost impact guardrails using the BTP Analytics cost savings versus control dashboard.
Okay, so they establish real-time thresholds for cost per autonomous transaction.
Exactly. If an agent breaches those predefined budget caps, the system automatically pauses the agent.
And concurrently, Basis activates those immutable log chains we discussed earlier, ensuring every micro-decision is cryptographically locked for the audit committee.
That's the playbook.
It sounds solid, but let's look at the actual mechanics of deploying this because I see a glaring vulnerability here. Let's say a new version of the production planning AI is successfully promoted through the ALG,
Good.
but its corresponding JSON-LD policy bundle lags behind in the ABAP transport pipeline. The AI goes live, it defaults to the older, more permissive rules, and it breaks that 10% forecast cap.
Ah, the policy version mismatch.
Right. Who owns that compliance breach? How does that mismatch actually happen in practice?
Well, the mismatch is a product of mixing two entirely different deployment speeds. Cloud-based AI agents can be updated via an API almost instantly.
Sure.
But the JSON-LD policy bundles, as we established, travel through the traditional ABA transport pipeline. Those transports often require scheduled downtime or, specific weekend deployment windows.
So you get this temporal gap.
Yes, exactly. The agent is living in the future, running optimized logic, but the back-end rules governing its behavior are stuck in the past.
And so the agent acts out of bounds, and if the auditor looks at the logs, the hash chain will simply report a missing policy version at the time of execution. The logs are honest, but the breach still occurred.
Precisely. From an accountability perspective, this represents a massive failure in orchestration between AI core ops and enterprise architecture.
It really does.
That temporal gap forces a total rewiring of how change management operates within the enterprise. You can no longer manage AI updates and policy updates in silos.
Which brings us to the broader implications. Implementing this runtime governance fundamentally rewires the organization's structure, the daily metrics they track, and quite frankly, their long-term vendor strategy. Let's start with that change management issue. How do teams prevent the agent from outpacing its own rules?
Change management workflows have to evolve to include agent change tickets.
Agent change tickets.
Yeah. These operate in strict parallel to standard transport requests. Their sole purpose is to track policy as code differences.
Okay.
A release manager can no longer promote an agent version without verifying that its corresponding agent change ticket confirms the updated JSON-LD bundle is already active in the target environment.
That makes a lot of sense. The impact on the finance department is arguably the most tangible, though. The Bosch Power Tools case study cited in the source material provides a great look at this.
Oh, that's a perfect example.
Before these guardrails, finance controllers were spending their days hunting through exceptions, basically running post-facto reports to figure out why an autonomous system routed thousands of microtransactions incorrectly.
They were completely drowning in the sheer volume of machine-generated transactions.
Right, but after implementing the real-time cost-impact guardrails via the BTP Analytics dashboard, they saw a massive shift. The auto-pause mechanism acts like a circuit breaker.
It stops the bleeding before the transaction completes.
Bosch reported that their finance controllers are saving roughly 40% of their time on post-order exception reviews. They are freed up for strategic analysis rather than playing janitor to a rogue algorithm.
It's a huge operational win. But the biggest structural shift, honestly, falls squarely on the Basis admins.
How so?
They are no longer just back-end mechanics managing database tables and server loads. They are evolving into custodians of the agentic governance layer.
That's a big shift in responsibility.
Massive. They have to manage the BTP AI core security architecture. They are shifting heavily into cloud-native identity and access management skills.
They're essentially becoming cloud-native AI compliance officers.
Exactly. And that shift feeds directly into how organizations must evaluate their architecture. Enterprise architecture boards must now track a brand new metric, governance debt.
Governance debt, it's a great term, but how is that actually quantified?
It is the measurable gap between the intended policy version, the JSON-LD bundle the architecture team designed, and the agent's actual runtime behavior.
So policy drift.
We call this policy drift, yeah. If your agents are consistently operating on older rules because of that transport pipeline lag we discussed earlier, your governance debt is accumulating.
Which means your risk is accumulating.
Exactly. High governance debt directly correlates with an exponential increase in audit findings. Monitoring that drift moves from a theoretical exercise to a critical daily control activity.
But there is a massive strategic cost to all of this unified, frictionless governance. We are paying for this control with our architectural independence.
Vendor lock-in deepens significantly here, doesn't it?
Oh, the lock-in is profound. The Agent Lifecycle Gatekeeper, the policy as code engine, the log chain service, these are all highly proprietary SAP mechanisms.
They are open source?
Not at all.
Yeah.
They are deeply integrated into the business technology platform. This creates immense migration friction for any customer attempting to run an on-premise S/4HANA environment while dabbling in agentic AI.
So it forces your hand. It actively forces the enterprise roadmap toward SAP BTP-hosted cloud solutions. If you want to deploy autonomous agents safely, you have to play in their sandbox.
You are buying raw automation speed and cryptographic safety, but the toll is total commitment to the BTP ecosystem. Listen, if you are finding this breakdown valuable and you are realizing how much the ground is shifting under your ERP architecture, you need to subscribe to the CRM Position podcast. It is the essential tool for senior professionals to understand how CRM and AI platforms actually operate under the hood. We break down the real mechanics of these platforms, stripping away the vendor hype to help you stay ahead of real architectural shifts rather than just reacting to marketing narratives. Make sure you subscribe to CRM Position today.
Absolutely. And to move from theory to execution, there are 3 concrete actions you should take this week.
What's action 1?
Action 1. Integrate those agent change tickets into your existing change management workflows. You must track JSON-LD policy bundle differences alongside your standard ABAP transport requests. If you don't synchronize them, you will fall victim to the policy version mismatch.
That's critical. Action 2. Establish a strict log rotation policy for the BTP logging store immediately. We discussed the performance overhead. If you enable immutable hash chaining for thousands of micro-decisions without a rotation policy, S/4HANA's compute will survive, but you will saturate the BTP storage.
Which is a disaster.
Right. That storage pressure degrades order-to-cash performance and can trigger cascading downstream outages in your CX, quote, creation agents. So rotate those logs. What's the third action?
Action 3. Audit your GRC analyzer configuration. Verify that it is not set to ignore agent-generated authorizations. You must ensure that autonomous actors are subject to the exact same segregation of duties checks as your human employees to prevent rogue, closed-loop approval cycles.
Phenomenal advice. As we wrap up this deep dive, we want to leave you with a final thought to mull over. We opened by comparing runtime governance to a cryptographic auditor riding shotgun with your AI.
Right. And accommodating that auditor requires a fundamental shift in enterprise philosophy.
How so?
Well, think about it. If true speed in autonomous ERP requires surrendering the traditional SAP authorization object hierarchy to a unified JSON-LD policy as code engine, are you prepared to abandon decades of classic segregation of duties matrices to unlock the actual promise of autonomous order release?
It is a massive question for any architecture board to answer. That cryptographic auditor might just demand you rewrite your entire governance rulebook. Until next time, keep digging deeper.